All right, so today we are going to talk about another type of measure that exists in statistics. And before we talked about the measures of center, the mean, the median, and the mode. And the measures of center kind of gave you the average, the center number, what is average about it. In measures of variation, we're talking about how the data changes from the smallest to the largest, or over the set of data, how it changes a little bit. So what I've done is I've already kind of pre-done a problem for you. I'm going to walk you through this of what I'm doing. And the numbers I've chosen to show you this example with is 8, 6, 9, 5, 5, 7, 2. And we're going to work with that set of numbers on the left-hand side. On the right-hand side, I'll write down exactly what I'm doing for you. So let's move on and let's come up with, how do you find the measures of variation? What are the measures of variation? And ultimately, what we're looking for in the long run, what we're going to look for is, are there any numbers in this set that don't make sense, that we call outliers? But let's get into this. So when we look at our first thing we have to do for the measures of variation, the absolute first thing we need to do is the numbers have to be put into numerical order. Just like we do with the median, which will become important, but the numbers have to be put in numerical order. So let's go ahead and write these numbers in numerical order. Voila, there we go. So if we put them in numerical order, you get 2, 5, 5, 6, 7, 8, 9. And so there we have, our numbers are now numerical, so it will help us make sense of all of our numbers. So now we're going to look for a new term, and this new term is called the lower extreme. Now, I'm going to be throwing a lot of new words at you, and they're abbreviations. So I'm going to find the lower extreme, or the LE. And honestly, folks, the lower extreme is nothing more than the smallest number on the list. So if you were looking for the lower extreme of our set of numbers here, what would it be? You're right. The lower extreme would be 2. It's the smallest number. Now, if we have a lower extreme, then of course we probably have an upper extreme. That's right. Not a higher extreme, but an upper extreme. And the upper extreme is the largest number. The largest number that you can have in your set of numbers. So in this case, what is our upper extreme? Yeah, the upper extreme is 9. So we have a lower extreme, which is 2. We have an upper extreme, which is 9. So now we talk about how far apart those are, and we have our range. And you'll notice here, I've told you the range is the UE minus the LE. It's also where the deer and the antelope play, but we won't talk about that right now. So we're basically, to find the range of numbers, we're taking the UE, the upper extreme, and we're subtracting the lower extreme. So in this case, it would have been our 9 minus 2. And if we do 9 minus 2, we get 7. So our numbers, the range of numbers is 7. Is that a big range or a small range? Well, we don't know that yet because our numbers were so small and we had a few of them. We won't know how this works in until later on. But that is the range of numbers. So the range is the UE minus the LE. Next, in our measures of to find the measures of variation, we actually have to find the median. We've done that before, but remember, the median is not a measure of variation. The median is a measure of center. It's giving us the middle number. So when we look at numbers, we'll do it, and we find that our median is actually 6. So we've looked at the middle number. We've gone from the edges and counted in, and we find that the median was 6. And remember now that the median not only is the middle number, but it actually divides the set of numbers that we have into 2 sets of numbers, into a low set and a high set. The low set is here, and the high set is here. Notice the median does not count in the set of numbers. Now, if there were 2 middle numbers and you had to add those up and divide by 2, that new number is the median, and those 2 numbers that you used fall into the set, the higher and the lower set. We'll try to look at an example of that later. But the middle number, the actual middle number, is the median. So now we're going to talk about what are known as quartiles. And a quartile, if you think about it, quar meaning quarters or fourths. So the lower quartile will divide our median, will divide our lower set of numbers into 2 parts. And of course, if we have a lower quartile, we're going to have a upper quartile. That's going to give us our 4 parts. And the lower quartile is nothing more than the median of the lower set of numbers. So remember, we're looking at our lower set of numbers. So those are those 3 numbers there. And now we're just going to find the median of those numbers, and that will be 5. So the lower quartile, in this case, is 5. Now, with this small of a set of numbers, it's hard to say it's a set because the set is 2 and the other set is 5 because the median was 5 as well. But it's that one number, so it both 5s don't count, just the one. We've already said if there's a lower quartile, there has to be an upper quartile. And the upper quartile is the median of the upper set of numbers. So now I'm looking at this set of numbers, the 7, 8, and 9. And what would be the median of 7, 8, and 9? Yeah, the median would be 8. And so the upper quartile is known as 8. So our lower quartile is 5, and the upper quartile is 8. Now, one of the things that we look at when we're doing this is we kind of look at what's known, we want to know the range of the quartiles. So we kind of call that the interquartile range. The interquartile range, or the IR, is the upper quartile minus the lower quartile. And that is going to be 8 minus 5, which means the IR is, drum roll please, 3. The interquartile range is 3. So that means half of the numbers fall within 3 of each other. The whole set was within 7, but half of the numbers, if you think about it, fall within 3 of each other. And we're going to talk more about that a little later as well, how that looks. Now, from here on out, this gets a little bit weird. Some of this is because of how things were developed, things statisticians look at. So don't ask me why right now. I'll explain more to you during the Zoom meeting. But the next thing we're going to look at is what's called the Quartile Constant. Now, I'll explain. We're going to lead to why we need the Quartile Constant in a second. But we call that the QC, the Quartile Constant. And what this is talking about is how far the numbers are away from the quartiles themselves, or from the median. And the way you find the Quartile Constant is you take the IR, the interquartile range, and you multiply it by 1.5. So you take the quartile constant, or the interquartile range, and you multiply it by 1.5. Well, our interquartile range was 3, which means the quartile constant will be 3 times 1.5, or 4.5. So that means that, they're about, the numbers are playing around with 4.5s. And I'll explain why that's so important to us, why we need that quartile constant. And we talk about what's known as the limits of our data. And we use these limits to kind of show how far spread apart our data really is, how far apart they are from the median and from the quartiles themselves. But in this case, from the median. So the lower limit is the LQ, the lower quartile, minus the QC. So think back, what was the lower quartile? What was the quartile constant? And then we subtract them. The lower limit was 5 minus 4.5. The lower quartile was 5. The quartile constant was 4.5. So we subtract those and you get 0.5. So we want to make sure that all of our data is nothing's lower limit, so nothing's lower than 0.5. Okay. Of course, if there's a lower limit, of course, there's an upper limit. And what do you think the upper limit's going to be? Yeah. The upper limit's going to be the upper quartile plus the quartile constant. So in this case, what was the upper quartile? And we know the quartile constant was. So then the upper limit is 8 plus 4.5, which gives us 12.5. So for our data to be sound, we don't want it to be below the lower limit or above the upper limit. And if it is, we call it an outlier. And an outlier is any number that is lower than the lower limit or higher than the upper limit. So in this case, were there any numbers lower than 0.5? No. Are there any numbers greater than 10.5? No. So that means that since there were none there, that means there are no outliers in the problem. So in this case, there are no outliers that we have to look at. And that, ladies and gentlemen, is how you find the measures of variation. And we're going to do this here. Oops. The measures of variation, you have the lower extreme, you have the upper extreme. Nope, that would not be an E. That's an E. And you have the range. The other ones, you have the lower quartile, you have the upper quartile, and you have the inner quartile range. And so those are measures of variation. And finally, you have a quartile constant, a lower limit, an upper limit, and an outlier, and outliers. Sometimes you're going to have them, sometimes you won't. Sometimes they'll be obvious. Like if my numbers were, 1, 50, 60, 70, 80, obviously the 1 is out of place. That would be an outlier. Sometimes it's not as obvious. Sometimes it is. But those will be an outlier. So those are the measures of variation. Now, one of the things that we also look at is how to, see the measures of variation. And a lot of times what we do is we make what's called a box and whisker plot. And in a box and whisker plot, you have to make a number line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're looking at a box and whisker plot. And in a box and whisker plot, you plot 5 different data values. Now, you have to make a whole number line, ladies and gentlemen. You can't just throw 5 numbers onto there. You have to do everything. And in this case, you plot these 5 points. On the number line, you do the lower limit, which in this case was a 2. You do the upper limit. Nope, sorry. Extremes. The upper extreme, which was a 9. You plot the median, which we knew was a 6. That's the median. We plot the lower quartile. We plot the upper quartile. And then what you do is this. You draw a line from the lower extreme to the lower quartile, from the upper extreme to the upper quartile, make a box from the quartile, from lower quartile to upper quartile, and you draw a line through the median. That's a box and whisker plot. What's kind of cool is that really shows you that my numbers were, in fact, broken into 4. Let me do it this way. We're broken into 4 different parts, quartiles. 1 part, 2 parts, 3 parts, 4 parts. And what that also tells us is that 25% of the data fit between the lower extreme and the lower quartile. 25 was here, 25% here, and 25% here. And it's kind of cool because I could say, like I said, half the numbers fit between the upper and lower quartile, because if 25 were here and 25 were here, that's a total of 50%. So that, ladies and gentlemen, is a visual representation of the measures of variation. I'm going to leave it with that. I'm going to give you tries to do on Google Classroom, not on Google Classroom, on Edulastic, to try this. We'll talk in Zoom tomorrow and see how well you did with it. So you may have to watch this a few times, rewind it, listen to it. I do suggest you write all the notes down for this one. And if you didn't, you may want to go back and do that. But it will help you, because this isn't something to memorize. This really is something to watch and learn and have your notes in front of you to do. Have a good night, and I will see you soon.